Okay, welcome back students. So firstly what we saw was what does quantitative aptitude means, why should we study it, then we moved on to first part. Okay, so basically we divided quantitative aptitude into two parts. The first one was the arithmetical ability, the second is data interpretation. But first we'll be covering the arithmetical ability. Then in arithmetical ability there comes the number system. So this is the first chapter that we are going to study. With respect to number system, I have wrote here some topics. Apart from these topics, also there are some other topics. We'll be covering it in the next part of the number system. So you can name it as lecture 1 of number system. With respect to number system, so first comes is the numbers. Basically what you can say, what are numbers? Yeah, numbers are nothing but, as we all know, you can say that yeah, the numbers are like 0, 1, 2, 3 and so on. There are various number systems. Basically we'll go with some plain concept, that is nothing but numbers. So basically all the numbers that we know are starting from 0. You know, Arithmetic, yeah, invented 0. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. So guys, these numbers, you might be saying only 10 numbers, yeah, but still only these 10 numbers, whole world, every value is represented using these 10 digits, 10 numbers you can say, okay. Therefore, numbers play a crucial role in our life. Yes, anything you can say, you will calculate and you will come to a number, yeah. For example, your salary, it might be anything, the cost of a gift or a toy that you want to buy, anything comes up to numbers. So I would basically say without numbers it would be very different life. It would not have been possible at all. Yeah. We directly say two eyes, two hands, five fingers. From our birth only, or you can say from the start of our life only, we get to know with the numbers. Yeah. So we live with the numbers. That is the one thing. Everything is unified with respect to numbers. You can say your phone number, yeah, it is just 10 digits, but you have a unique number. Why? Because these values get added to your phone number. Similarly, your card number, there we use this, we also use alphabets also, yeah, the combination. Similarly, this is the crucial part played by the numbers in our life. So but there is interesting thing about these numbers also, that is this is this topic. So we will be studying various types of numbers also, the face value and place value of a digit in numeral. So let's get back to the second topic. So first was just introductory part, that in our Hindu thing or in our Hindu numerals, you can say there are these numbers. And if you want theory, so with respect to theory, a number is denoted by a group of digits, that is called numeral. So a number is defined by a group of digits, that is called as numeral. So we can say this is one numeral, this one numeral, yeah, these all are numeral, and this is group of these numerals. This is nothing but the number, yeah. And to define a number, we use the place value chart. Okay, we use a place value chart. For example, if there is one single number, this is 2, we'll call it as ones. We'll just draw here roughly, yeah. If the number is 12, okay, 12, so this is tens place, you can say. How? See, we are adding this, nothing but we are adding this, right? This is ones, this is tens, yeah, this whole is tens, the multiple of tens, you can. Similarly, we'll go in detail. For now, you just look. It will be easier, guys. It will be easier. As you move ahead, it will be easier. Yeah. So this is tens. For example, if the number is 312, okay, this is hundreds. This place is hundreds. Then I want to add this number and make it as 5312. Okay, this is 1000. This thousands place. Yeah. Then suppose let's go ahead with 95,000. Yeah, thousand, tens thousand. Yes. Then we'll come in with respect to, now here there are two chances. You can also say lakhs, that is our Indian system, and hundreds thousands. Okay, hundreds thousand. That is also you can say hundreds thousand. So overall the number is nothing but 8,95,312. After this, you can go. Also, million will come into place, which is 10 lakhs for us. Then 100 lakhs, it is again you can say 1 crore for us. So that is the system, that is simply you can understand, right? So depending on these values, how it is decided that this is tens place, this is hundreds place, this is thousand place, nothing else. So let's go into detail. Now let's play with this number. So this number over here, you can say how it came into picture. This you can say 1. Yeah. This is tens place. You can write it at. So first of all, what I will do is I will just delete this. And then over here, this is 300. This is 5,000. Here comes 90,000. And here comes 8 lakhs. You can say 800,000. Yeah. But this you can write over here as 2 into 1. This you can write as 1 into 10. I can directly write 10 also, but there is something you will get to know now. This is 3 into 100. Similarly, this 5,000 will be 5 into 1000. Again, this 90,000 will be 9 into 10,000, and this 800,000 will be 8 lakh. Yeah. So see, these were the places. Yes, these were the only numerals. Again, we are coming back to numbers. So basically, what are the main numbers? This 1 and 0. Yeah. So this is again therefore called ones. This is called tens. As you can see over here, it's at tens place. It's hundreds and thousands and thousands and 100,000s. Yeah, isn't it easy? So let's see topic. Next one, that is I hope you guys it's engaging. I know it is very hard to teach online. I don't have students in front of me, but any of you, if you have any doubts, please you can ping in the comment section and keep subscribe so that you will get to know when new lecture comes. After this, we'll be moving towards the next topic. Yeah. And so just now we saw face value and place value. Okay. So what is face value and what is place value? For example, we will study a number called 6,872. So this is, you can say, take it as an example also. We will be taking many examples in between. Face value and place value. So face value is nothing but the number itself. Okay. So over here 2. So 2 can be, I will write F for face value, P for place value. So face value of 2 will be nothing but 2, and place value of 2 will be what? It will be ones. Yes? So this is the thing. I hope you guys are getting. And because of it is ones, so what you will do is multiply the face value with the ones, that is nothing but 1, which will give it to 2. So this is the place value. Yeah? Place value means multiplying the number, that is the face value, with its place value. Okay, the place value can be defined as the position at which the number is there. Okay, for example, for 7, you'll get to know, it will be easy. 7, the face value will be same as I told you, but the place value over here is 70. Why? Because earlier I broke that whole number into ones and tens and thousands. Okay, so similarly this is 72, right? 70, hold that 70, and that is the place value. The face value is 7, but the place value is 70. Similarly for 8, what it will be? 8 will be the face value and the place value will be 800. Similarly for 6, the face value will be 6 and the place value will be 6000. I will write here 800. Similarly here 6 and the place value will be 6000. Yes, got it? You can similarly play with other numbers also. This is simple topic, I won't go much into detail. You guys keep on touching this topic. These are basics. These are easy to capture also. It's not much more hard task. Yeah. So till now, what we saw was face value, place value, what are numbers. So these topics are also covered. So we covered 2 topics till now. Numbers we saw, in the face value and place value. Let's move on towards various types of numbers. So first of all, what are natural numbers? Simple words. Counting numbers, you can see. Counting numbers. Simple. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, these are the natural numbers. So counting, from where will we start? We will count some quantity, right? It will be 1. From 1 we will be start. From 1, 2, 3, 4, and so on. So these are the natural numbers. But for whole numbers, there is something missing. Yeah? For whole numbers, there is something missing. So set of whole numbers is nothing but 0 with natural numbers. So over here, it will start from 0, 1, 2, 3, 4, and so on. That is the difference. That's it. You can simply remember whole. This represents the 0. It's none of the logic, but just to remember. Natural has a no. Okay? So it doesn't have 0. So natural starts with 1, 2, 3, 4, and so on. 5, 6, 7. You can go to infinity. Similarly, for whole numbers, it will be starting from 0. 0 is inputted. Okay? Similarly, with respect to On line also I will be showing. Yeah. So natural numbers 1, 2, 3, 4, 5. Okay. These are the natural. For whole numbers, start with 0. 1, 2, 3, 4, and so on. Similarly, for integers, what are integers? Integer. Yeah, this you can say set of, we're including 0, natural numbers and negative natural numbers. For example, if you draw on a line over here, 0 is included, same as whole numbers 1, 2, 3, 4, and so on. Similarly, on the left hand side, with the negative values, -1, -2, -3, -4. Over here, I would like to give you one note that the value, right, -1 is lesser than 0, -2 is lesser than -1, -3 is lesser than -2. Okay, so this is the increasing order. Okay, don't mistake that -4 is greater than -3. No, -3, when you subtract one more -1 from -3, then it will become -4. Simple as that. Okay, so we are reducing one value from -3, then we are getting -4. Therefore, -4 is lesser with respect to -3. So remember this. Okay, then we will be moving towards even numbers. So even and odd. So these are basically, many questions are made on this two type of numbers also. So first of all, let's revise. We covered natural, whole, integers. With respect to even, what will happen in even numbers is 0, 2, 4, 8, and so on. 0, you can say even numbers are nothing but 0 plus or set of 0 and all the numbers which can be divided by 2. All the numbers that are having 0, 2, 4, and 8 at their end. For example, simple, what is this? 247. Is it even number? Can you see any of this digit, any of this number at end of it? No, this is not even number. Similarly, if I give you a number 346, also 6 will be here. Just note it, because 6 is also divisible by 2. So 346, you have 6 at the units place. So units place you have 6, that is nothing but divisible by 2. Yes, it is an even number. This isn't. For example, one more. Is it? Obviously, 2. It is even number. Yeah. So you got to know what are even numbers. Then we will be moving towards odd numbers. Odd or what? Number which are not even are odd. But we can't say it like that also. The number which are not divisible by 2 are odd. And 0 is not included. Okay. Odd number starts with 1, 3, then 4, skip 5, then 6, skip 7, and so on. These are the odd. So now what you can say, I will give a statement. The set of even numbers as well as odd numbers is whole number, is a whole number set. Is it true or false? Yeah, comment, let me know. Okay. So now let's see what are prime numbers. You might have heard many a times what are prime numbers. Yes, it is simple. Now prime numbers are nothing but any whole number, yeah, any whole number which has two factors. That is, any prime number which has two factors, and one of the factor is 1 always, and the second can be the number itself. So there are two factors. The first one is 1 and the second one is the number itself. How? So let's see. I am taking a number and then we will see. So for example, let's take 4. 4. So just ignore for now and tell me what type of number it is. Is it a natural number? Yes. Is it a whole number? True. Is it an integer? Yes, because 0, negative natural numbers, positive natural numbers. It comes in positive natural number. Is it even? Yes. Or no. Okay, just a checklist. Now prime number. So we are considering 4. Okay. So with respect to 4, if you see, what are the factors? Factors means simply for now you consider in which table it runs. So I will give you option. We will just type these numbers. Yeah. So 4, does it come in one's table? True. 1 4s are 4. So you can say 1 is its factor. Yeah. The second is 2. In 2's table, does 4 comes? Why not? 2 2s are 4. So 2 is also a factor. Similarly for 3, does 4 comes in table of 3? No, right? So no. 4, yes. 4 ones are 4. So just now we said prime numbers are the numbers which have two factors. One should be always 1 and second should be the number itself. No other factor. Only these two factors should be there. So if you see now clearly, for 4, 1 is a factor. Yes. So already we met one thing. Now for the second, the number itself. Is it 4 ones are 4? Yes. So this also criteria is fulfilled, but still remember there is one thing, that is 2 is also factor. Okay. So 2 is also factor. So 2. But what is the definition of prime numbers? The prime numbers are the numbers which have two factors, out of which one factor is always 1 and the second factor is the number itself. No other factor should be there. If there is, then it isn't a prime number. I hope it is clear and easy. I made it as simple as possible. So this was with respect to 4. Now let's see some other example. Take a number 13. Now we will check whether it is a prime number or not. With respect to one's table, you should be always clear that in one's table it will always come, right? 113 is a 13. Apart from that, in 2's table, will it come? Obviously not. 2 6 are 12. After that, we move towards 14. In 3's table, will it? No. 4's table, not at all. 5's table, not possible. 6's table, 6 2s are 12. After that, we move towards 18. Not at all possible. 7, no. 8's table, no. 9, 10, is it a factor of 13? No. 11, 12, 13, yes. It is. So first factor is 1, second is the 13, that is nothing but the number itself. So can I declare 13 as a prime number? Yes. So this is one thing. Now let's move towards this set of number, that is composite number. Okay. So what are composite number. So now till now we saw various types of numbers. Yes, we saw whole numbers, we saw natural numbers, we saw integers, we saw even numbers, we saw odd numbers, we saw prime numbers, and now we move towards the composite numbers. So it's simple. As I told when we were studying odd, that the numbers which are not even are odd. Similarly, and this value holds true for composite. Like for composite, it is like the numbers which are not prime numbers are nothing but composite numbers. So, with respect to the theory of this, what you can say, a number which has more than two factors. Yes. So you can say composite numbers are nothing but more than two factors. And these two factors we are already considered. One is also there, the number itself also is there. Apart from these two, there will be more any numbers which will be factor of that number. Okay, so this is composite. For example, composite, you can say if we write prime numbers series over here, 1 is a prime number, 2 is a prime number, 3 is a prime number, 4 no, 5 yes, 6 no, 7 yes, 8 no, 9 no, 10 no, 11 yes, 12 no, 13 yes, and so on. So one more task, guys, just pin into the comment that I want you all to comment first 50 prime numbers, and I want you to do by yourself. Don't Google it, don't search it online. Just write first 50 numbers. It will be very much helpful for you. Yes, that concept will be fixed in mind. Yeah, I don't tell. Yeah, first 50 might be hard for you, but try at least 20. Okay, let's make it 20. I have wrote over here how many? 6, 6, 7. 7 I have only wrote. Yes. So just go ahead. Let me know what are the prime numbers. Composite is now clear. Now we move towards what are the perfect numbers. So for now, perfect number is nothing but with respect to factors only we are studying. Yeah. So let's move towards perfect numbers. What are perfect numbers? So I will just drop this. Okay. Or I can write over here. Now for perfect number, a number to be perfect, what is the definition is? Suppose the number has three factors, f1, f2 and f3. So when you add these all factors, excluding the number itself, then it should come, the sum should be the number. Then it is called as number. To make it easy, let's see 6. Let the number be 6. What are the factors of 6? I will let you know. Okay. So first of all, you also might be knowing, you can also solve side by side. So first is 1. Is it factor of 6? Yeah. 1 is factor of every number. Then 2. Yes. 3. Yes. 4. No, it isn't. 5. It is not. 6 is the number itself. Okay, so we won't go ahead now. So we have these 3 factors. Now let's add them. 1 plus 2 plus 3. And it adds up to 6. So what is a perfect number? I already told you. Perfect number is a number if we add its all the factors excluding the number itself, then the sum should be equal to the number. So over here we will be getting 6. That is nothing but the number, right? So can I say 6 is a perfect number? Yes. Similarly, guys, so this is simple. I just want you to give me 5 examples of perfect numbers in the comment. This is one task. Let's move towards co-prime numbers. What are co-prime numbers? With respect to co-prime numbers, or you can say relative prime numbers. For example, co-prime are nothing but the numbers whose highest common factor. Okay, the highest common factor is nothing but 1. Those are the co-prime numbers. Okay, I will clear this also. I guess you guys have cleared all the doubts. If you have any, let me know in the comment box. Be at your utmost help. So co-prime number are the, for example, this set. Okay, suppose for example you are considering two numbers A and B. So for these two numbers, the HCF should be 1. No other factor should be there in common. Highest common factor of A and B, if it is 1, then they can be told as co-prime numbers. So let's see over here. Let's take an example. R1 and 2 co-prime. Yes, they are correct, because the factor HCF is 1, right? Highest common factor. Similarly, if we see for 2 and 3, what is the highest common factor? 1. Okay, let's check 2 and 4. Are these co-prime? No, because 2 is the highest factor. These are not. Similarly, if we go for 6 and 8, what is the highest common factor? 2. Cancel. So similarly, you might be knowing, and depending on definition, please give 2-3 examples of this also. This is simple. The two numbers which have highest common factor as 1, those can be stated as co-prime numbers. Now we have twin prime numbers. What does twin prime numbers means? So two prime numbers whose difference is 2 are called as twin prime numbers. So over here, twin prime numbers. Co-prime doesn't mean exactly prime numbers. Any two numbers whose HCF is 1. But for twin prime numbers, they should be prime numbers, and also the difference of these two should be 2. For example, we'll take a set of twin prime numbers. 1 is a prime number, yeah. 2, yeah. What is the difference? 1. Is it a twin prime? No. Why? Because we expect the difference to be 2. 2 and 3 are prime? Yes. Are twin prime? No. 1 and 3 are prime, right? Are twin prime? Yes. So the difference should be equal to 2. I hope it is clear. It is a simple topic, not much more complicated. Now let's move towards the rational numbers. So what is the definition? The numbers which can be expressed in the form of p by q, where p and q are integers and q is not equal to 0, are called as rational numbers. So rational numbers are the numbers which can be expressed in the form of p by q, where p and q are integers. And also one more condition is there, that is q need not be equal to, should not be equal to 0. So for example, I will write, so you should say whether it is a rational number or not. 8 by minus 11. 8 is an integer. Yes. Minus 11. The integer is q. That is minus 11 equal to 0. No. So it is a rational number. 9 by 9. We will say it is 1. But still, we can make it into form of p by q. So p is 9, q is 9. And q is not equal to 0. Both are integers. True. This is also a rational number. So any number which can be written in the form of p by q, where p and q both are integers and q should not be equal to 0, then it is called as a rational number. I hope this is also clear. Okay. Now let's move towards irrational number. What does irrational number means? Irrational number is simple. The numbers which when expressed in decimal would be in non-terminating and non-repeating form are called as irrational numbers. Okay. So when they are expressed into decimal, for example, if you, what is root 2? 1.414, yes. And similarly root 3. So these values, right, these are what, terminating or non-terminating? This should be non-terminating and non-repeating form are called as irrational numbers. For example, root pi you can take, epsilon you can take, yeah. These all are 1 point anything like 4, 2, 3, 5, 6, 7, 1. Yeah. So these are irrational numbers. Got it? They should be non-repeating form. For example, what is 1 by 3? 0.33333. Is it an irrational number? No. Is it a rational number? Yes. Integer, integer, p by q form, q is not equal to 0. But is it an irrational number? No, it is rational number. Okay, because it is repetitive. So I hope this is clear. So we studied various types of numbers. We studied face value, place value. We studied numbers, and so this was the first lecture on number system. We'll get back to you on second lecture soon. We'll be covering theory of that topic, and after that we'll be heading towards the solutions of various numericals. We'll be covering good number of numericals. A special session will be there based on numericals. This will be theory lectures, the part 1 and part 2. So this was number systems part 2, part 1, sorry. Part 2 will be coming soon, and I hope you guys have enjoyed this. If you have really enjoyed, please like, share, subscribe, and keep on watching the channel. You can also click the bell icon to get updated about the upcoming lectures. So we covered number system part 1. Thank you so much.